Hello everyone! Welcome back to Doc Gilmac Online Tutorial. Doc Gilmac Math TV Basic Calculus Tutorial. Are you ready for the next tutorial? If you are ready, so let's begin. The topic I will be discussing for today's tutorial is all about basic derivatives on power rule. Let's recall what is the derivative in calculus. Derivatives are a fundamental tool of calculus. The derivative of a function of a single variable at a chosen input value when it exists is the slope of the tangent line to the graph of the function at that point. The tangent line is the best linear approximation of the function near that input value. Power rule differentiation. So I will be showing you the three power rule differentiation formulas. Number one, we have d over dx of x raised to n is just equal to n times x raised to n minus 1. Number two, d over dx of the quantity c x raised to n is just equal to n times cx raised to n minus 1. d over dx of the quantity f of x raised to n is just equal to n times the quantity f of x raised to n minus 1 times the derivative of f of x. So take note of that. Consider illustrative example number 1. d over dx of x raised to 5. As you can see, the exponent here is 5. So applying the power rule, we have 5x raised to 5 minus 1. Simplifying further, this is just equal to 5x raised to 4. Consider illustrative example number 2. This time, d over dx of x raised to 8. The exponent is 8. Again, applying the power rule. So we have here 8 times x raised to 8 minus 1. Simplifying further, this is just equal to 8x raised to 7. Consider illustrative example number 3. d over dx of the quantity 2x raised to 10. This time, we're going to determine the derivative of a constant times x raised to the power n. So applying the power rule, we have here 2 times the quantity 10 times x raised to 10 minus 1. Simplifying further, this is just equal to 20x raised to 9. Consider illustrative example number 4. d over dx of the quantity 3x plus 5 raised to 2. This time, we're going to apply the third power rule. Okay, the exponent of a function. The function is raised to n. Okay, so this is simply equal to 2 times the quantity 3x plus 5 raised to 2 minus 1 times the derivative of 3x plus 5. Take note, the derivative of 5 is 0 and then the derivative of x is 1. So, the derivative of 3x plus 5 is 3. Simplifying further, we multiply 3 by 2. So, that is simply equal to 6 times the quantity 3x plus 5 raised to 2 minus 1 is 1. So, we have here 6 times 3x plus 5. Applying distributive property, so we simplify further. 6 times 3x is 8x plus 6 times 5 is 30. So this is just equal to 18x plus 30. Consider illustrative example number 5. d over dx of the quantity 4x minus 2 raised to 3. This is just equal to 3 times 4x minus 2 raised to 3 minus 1 times 4. Applying the power rule differentiation for a function f of x. Take note, the derivative of 4x minus 2 is 4. Since the derivative of 2, which is a constant, is 0, and then the derivative of x is 1. Simplifying further, we have here 4 times 3 is 12, times the quantity 4x minus 2 raised to 2. Simplifying further, we have 12 times 16x squared minus 16x plus 4. Applying the square of binomial. Simplifying further, applying the distributive property. So we have here 12 times 16x squared minus 12 times 16x plus 12 times 4. So this is just equal to 192x squared minus 192x plus 48. Again, I would like to thank you for watching Doc Gilmac Math TV. Stand by for my next tutorial. Stay safe everyone, and may God bless us all.